Alrighty, it's 11 o'clock, so I'm going to go ahead and get started. All right, so yeah, the title of this talk is A Journey in Shared Code with Kotlin Multiplatform. My name is Ankush. I work at a company called Quizlet. We're headquartered in San Francisco. So yeah, that's what the talk's officially titled, but it's really more about the journey than it is about the Kotlin Multiplatform. So just a fair warning that a lot of this is going to be talking about how we thought about shared code and eventually ended up using Kotlin Multiplatform. So first, I'm going to start off with a brief history of Quizlet. Quizlet is a pretty old company. It actually started back in 2005 in a high schooler's bedroom because he did not like having to handwrite flashcards for French class. Quizlet's a online study platform, and he used the greatest and most amazing web technology of the time to make this work, which in 2005 was PHP. We made at the time most of our money off of ads. It was kind of a self-sustaining business with no external VC funding for well over 10 years. And somewhere after 2005, this mobile thing took off. People expected apps and not just mobile websites. But also, Quizlet, the official Quizlet team, was very small because we didn't have money to hire everyone that we wanted to. So in 2012, a high schooler ended up using our public API to write a very basic Quizlet app to help them study. Seems to be a common trend. And what we ended up doing was we brought this iOS app in-house and hired this high schooler, and that became the official Quizlet iOS app at the time. And also, in 2013, Quizlet took on a college freshman, me, who also was upset that there was no Android app for Quizlet. And so I wrote the very first iteration of what eventually became our current Android app. But, you can see there's a pretty big gap between 2005 and 2012. And in fact, in 2012 and 2013, when we were writing these apps, we're starting from scratch. We're focusing on the very basics of just getting the data and displaying it. So while we were doing that, time didn't really stop for web. Quizlet grew organically by word of mouth with learners and teachers all over the world. It kind of developed into this general purpose study tool full of a lot of different content for a lot of different types of people. So tens of millions of users ended up joining the website, and we ended up having millions of different study sets that these users are trying to create. It's all user generated, so whatever someone is trying to learn, they'll end up putting on Quizlet, and someone else can study it. This stuff span thousands of different subjects. Whether you're trying to learn animals in German, or you're in med school trying to learn the organs of the human body, or you're just trying to learn how to, what the recipes for classic cocktails are, someone is trying to learn it on Quizlet, and this is all very different types of learning material. And that's kind of when what I like to call our secret sauce took off. It's a lot of different content, a lot of different people, and there's a lot of different intricacies that go into learning that stuff. So I guess, show of hands, who here understands what I'm talking about when I say a CRUD app? All right, so not everyone, but a decent amount of people. So CRUD, C-R-U-D, stands for create, read, update, delete. And for a lot of apps, the core functionality is you talk to a web service or a database, you create models, you read back models that you've created, you can update those models, and you can remove them. And for many apps, that's all you really need, and that's not a bad thing at all. That's, at the core of it, that's what most apps are doing. They're talking to a web server or even just doing it all locally, and they're just displaying all this stuff in recycler views, and that's completely fine. That's great. But for us, we had a lot of more complex things that we ended up needing to tackle once we had gotten this core functionality down. Things like, when you have millions of users studying, millions of different things, you need to start thinking a little bit more structured about how you represent this data for analytics. So things like just having standardized enums and logging events. Going a step further, if people are studying a bunch of different stuff, you can't just do string comparisons to say, did you type in the exact right answer? You need to start thinking about the context around what they're studying and what they're typing in. And then once you get a little bit further into it, later along the Quizlet product pipeline, we started, looking at the latest cognitive science research. Not every user remembers the exact same material the exact same way. So we started, looking at the latest developments in cognitive science to try to model on an individual user basis what is the next best thing for you to be studying. And I linked to a blog post at the bottom down there. That's the title of the blog post. You can get the slides later, and that's a clickable link. But this kind of stuff is not usually within the wheelhouse of an Android developer or a web developer or an iOS developer to tackle independently. So just as some examples of our grading system, if you're learning English and the right answer is this shorthand version of ham and cheese that some user typed in, you want to be able to type in the word and. We let you substitute, like the word and, the ampersand symbol, or the plus sign interchangeably when you're just learning English. If you're learning math, that's not exactly the same thing. So like x plus y maybe shouldn't be treated the same as the text x and y. If you're learning Chinese, there are a lot of diacritical markings that are in the standard kind of Romanized representation for Chinese. But if you're on a mobile device or on a keyboard, it can be kind of tricky to type all that stuff in, especially on like a physical computer keyboard if you don't know all the right shortcuts. So for that reason, there's this standardized method of typing this stuff in called pinyin, where you represent these different diacritical markers with numbers. And if you're studying Chinese, that's something that you want to be able to do. But if you're studying chemistry, we don't want to start mixing up those characters and treating them the same way. It can keep going on and on from here. Like we allow you to reorder things by default. We also have configurable settings. So by default, we let you reorder things. Maybe you don't have to. And as we start introducing more settings, you have to start thinking about how you introduce those to your users. So now we start having things like, hey, if you enabled this accept partial answer studying, you could type in apple instead of apple and banana. So we start getting more and more complexities in here. And as you get more and more languages, as you get more and more different types of users who expect different things, or they're learning from different teachers who accept different potential right answers, this starts to balloon. And if you're writing it once, it's okay, I guess, to keep doing it. But for us, writing this code for web was hard enough. Porting it to iOS and Android so that these apps worked offline. So if you're just doing it on web, you could potentially rely on the fact that users might have a web connection and use it as an API. For us, offline functionality was a big deal because a lot of times students don't have data plans, or a lot of times people in developing countries who are trying to learn things don't have access to that. So that's a big part of our mission, is to make sure it's accessible to everyone. But you can't do that if you don't also have it working offline on these apps. So for us, on Android particularly, we were stuck playing catch up. Like whenever something new would come out, we would have to just rewrite it all ourselves. And it meant that we couldn't necessarily be innovating there, and it meant that a lot of the times we were spending most of our time just rewriting stuff and validating that it worked. So that kind of brought us to this kind of standstill. We could either decide, hey, if we want the mobile apps to have feature parity with the web, we can slow things down. We can make sure that we're taking the time to develop it. Or we could double down. We could invest a lot more in this stuff. We could hire more people. We could, just make sure we have entire teams dedicated to just rewriting the same code. And as I mentioned, we were a very small team at the time. We hadn't taken in external funding. We were just bootstrapped based on whatever we could get from ads, and then at this time, people were starting to pay us for some additional features. So we couldn't justify hiring people just to rewrite things. And this is kind of where we started becoming in the idea of shared code. This kind of thought that if you can write it once and run it everywhere, which is kind of like the holy grail, then maybe we wouldn't have this problem anymore and could focus on like the cool innovations in learning instead of just rewriting the same thing. And as you think about that, you kind of realize developers are opinionated enough when they're working on one platform. And as you try to force people on 3 different platforms to do the same thing the same way using stuff they're not familiar with, it's really hard. Each platform has its own kind of best practices that people want to embrace. Each platform has their own quirks that you kind of want to avoid. And so for us, what we kind of realized was it would have been very difficult to use shared code for things like the UI. It would have been difficult for us to use shared code for things like the persistence or networking or serialization layers, especially because other companies were already innovating in making that stuff easier, and we were way too small to think that we could make a dent in this. If we're already using something like retrofit on Android, that's probably a lot easier for us to use than it is for us to write something ourselves that would be better and scale across platforms. So instead of kind of focusing on what a lot of companies are sharing, which are these basic create, read, update, delete functionalities, we decided, why don't we focus on what makes us different instead? So new engineers coming in, whether you're an Android engineer, whether you're a web engineer, whether you're an iOS engineer, typically you know how to do the basics of your operating system. You know how to hit an API generally. You know how to display stuff. And maybe you're using a slightly different library, but the basics are generally all there for your platform. But what usually wouldn't happen is you'd hire a new engineer and they would be intricately familiar with German grammar. You're not going to hire a new engineer and have them be experts in brain and cognitive science. So this is kind of what we decided is the important thing to share. This is what we realized was if we keep innovating in these areas, it'll help us grow our business much more quickly. And at the same time, if we hire engineers who know what they're doing on their own platforms, we wouldn't have to innovate on that end, and instead we would be using the latest and greatest from other contributors to those fields. So yeah, this is what we decided to share. And you're probably thinking, sweet, time for Kotlin Multiplatform, but it's not. At this point in time, it's early 2016 for us. We decided we wanted to share code in early 2016, and Kotlin was barely a thing at that point, let alone Kotlin Multiplatform. So we're using the best tools that we have at our disposal, which is shared JavaScript. So we already had all this code running client-side on Quizlet.com. It's like we had web engineers who were on a team that was much more staffed than we were as Android engineers. Why don't we take that code that's already running in browser on web and just make it run on mobile? How hard could that be? So on iOS, there's this built-in framework called JavaScript Core. This is a framework that Apple develops, Apple ships, Apple uses for Safari, and it's not trivial to use, but it's kind of a no-brainer that when you're doing JavaScript, when you're trying to run JavaScript on iOS, you use this because everyone uses the same framework, everyone has the same questions. You can file a radar with Apple and they'll fix it because everyone's using it. On Android, it's a little trickier. You can start out by using a web view, and eventually you start running against some fun problems, especially different manufacturers have different implementations of WebKit on their devices. It's not fun. So eventually, we settled on this library called J2V8. We have another blog post that one of my coworkers, Damien, wrote, where we compared, I think, 5 or 6 different potential ways to run JavaScript on Android. And we ended up settling on J2V8, which takes the V8 engine from Chromium, compiles it with the NDK, and then wraps it in with the JNI so you can call it from Java. It's this really complicated bit of code, but at least it's the same JavaScript everywhere, and it was the most performant one that we found. So we took all that secret sauce and ended up with these 5 different libraries. We had our cool shared code written in JavaScript, and we would write these things as parts of our web code base, and we would have separate scripts that would take and say, all right, I need the latest version of the grader. I'm going to grab the grader, everything that depends on the grader, put it all into one big JS file, and then handwrite the public API for this method in Java or in Swift or, I guess, Objective-C at this time. And, it wasn't great. But the thing is, it worked. Like, we were able to share this code across platforms. We didn't have to rewrite the bulk of this code. It wasn't without its problems. Performance on iOS and Android was not comparable to native code. We had performance degradations there. Things like marshaling data into JSON, to and from JSON, is not free. Even though we picked the fastest engine on Android, it was slow. It was much slower than it had to be. APK size was a really big one. Back at this time, we were not splitting by ABI for Android, and J2V8 is faster than the other JS engines, not as fast as native code, but it's also the biggest. It was actually around 3 megabytes per ABI, and so for us, that basically doubled our APK size. We added around 10 megabytes total just to run shared JavaScript. It's also not the most safe. As I mentioned, J2V8 takes this C code, compiles it using the NDK, wraps it in a Java wrapper, and then we're passing in this really big raw string from this JS file that we have, and then passing in even more strings of JS objects that we have serialized from real objects. And if anything along that chain breaks, it's not very easy to debug it and figure out where it is. Your stack traces, you have this long string, you're given this random position in the string, and then you have to go back and correlate it with that JS file that's minified and uglified. It's not a fun experience. And so that had a big impact on developer confidence as well. Web folks felt at home. They're writing in web, and we're, as Android engineers and as iOS engineers, we were kind of stuck just taking that and using it. So this is, it wasn't great, but it got the job done, and it actually got the job done for quite a while. As we if we had stopped here, it wouldn't have been perfect. All of these problems would still exist, but it still would have been a win. We still were able to work quickly on these kinds of cool features that help make Quizlet unique and take advantage of the fact that we're hiring engineers who already are familiar with their own platforms to kind of work on the things that are shared across multiple different apps. But in November 2017, shortly after Google kind of announced that Kotlin's officially a big thing and officially supported for Android, something was announced that caused us to kind of rethink things. It was Kotlin Multiplatform. At the very first Kotlin Conf, Kotlin JS was already a thing. It already existed. Kotlin Native, I think, was either very recently announced or it's still very, very rough around the edges. But JetBrains announced this thing called Kotlin Multiplatform. It was very interesting because of the model that it treated this kind of idea with. You have common code, which is written in platform-agnostic Kotlin, and you can add things to it that are specific to each platform. You can call java.util.date, but only on the JVM. So you have to silo that into your JVM-specific code. You can call, the JS date object, but only within JS. So that gets siloed into JS. So what's interesting about Kotlin Multiplatform to us is that it wasn't trying to force us into the same kinds of things we were worried about, where you have to deal with weird abstractions over things like the UI or the data layer, because you can call real Java code, you can call real JavaScript code, and you could call real native functions as well. It's like, it was just a very different way of thinking about it. And so we were thinking, hey, why don't what would happen if we apply this to our shared libraries? And so reflecting back to where we were with our shared code, what we were calling shared code was not really shared code. It was web code that we kind of forced onto iOS on Android. If we wanted to get serious about it, we were saying, hey, why don't we think about it as a first-class citizen the same way Kotlin Multiplatform thinks about common code? It could be, versioned independently from web, live somewhere else, and then those artifacts, the JS artifacts, the JVM bytecode, the native frameworks can be pulled into the actual platforms. Kotlin Multiplatform wasn't really the only way to do it, the only way to get, a jar file that you can run. But it was the first thing that got us thinking along these lines, just because we happened to be focusing on Kotlin as an Android team. So that's what I ended up proposing to our entire engineering team. Why don't we explore Kotlin Multiplatform? And I'm an Android engineer, so for me, Kotlin's like, sweet, this is a cool new thing, this is awesome, we should keep using it. And we were using it on Android, we should use it everywhere. But I'm an Android engineer on a mostly web team. So, the vision felt right, but Is it just, is it just like, oh, it's super hyped up right now? It's like you have to be understandable that the web team is going to be very skeptic of it, because we were also skeptics of it, but we thought it was worth trying out. So we basically realized we need to be open to the fact that maybe we're wrong. Maybe Kotlin Multiplatform is not the right way to do it. So thinking along the same lines of what we thought were the weak points on Android, all of these things were concerns that, hey, yeah, these are weak points on Android and iOS, but these are strengths on web. Performance on web, which is where the majority of our users are, is really good. The bundle size is really small if you're using real JavaScript. Stability, it's just as stable as the rest of our web code. Debuggability, it's just as debuggable as the rest of our web code. Why are we throwing a wrench in this thing that's already working? So these are the kinds of things that we need to be critical of when we were trying out Kotlin Multiplatform. So the way we did this was we kind of settled on 2 phases. First, we would identify like a really small but significant chunk of code, something that, it can't be trivial, because then it's not going to get us a good idea of what it's like to actually work with the technology. But it also can't be like the entire shared code base, because that's a little crazy to dive straight into. So, and if that's successful, then we come back and maybe think about doing the rest of the code. So that's basically what we did. We decided, all right, this grading logic, which is complicated from a total lines of code standpoint just because there's so many rules, but at its core, it's a rules engine. You have like conditions. Do you apply this rule? Then you have the transformation of if it is, this is what we transform and this is what we simplify the representation down to, is kind of how we represent it. So at its core, it's a pretty simple piece of code. So that was what we decided to do. So yeah, we had to port that rule engine into Kotlin. It was time consuming because of the sheer quantity of rules. But we basically just did a straight file-to-file port. Let's take each JS file, each like class in JS, and just rewrite it as a Kotlin class. Let's not try to do anything too crazy. Let's not use any exotic Kotlin features, because at this point in time, we're just trying to see, is it going to work? We're not trying to see how awesome is it and fast and elegant is our code going to be. We just want to say, hey, can we get a version of the grader to compile for the web, Android, and maybe iOS? And we got it to compile. But compilation isn't necessarily the same thing as correctness. As I mentioned, there's hundreds of rules. How can we be sure that every single thing is correct? A lot of this code is using regular expressions. How do regular expressions get handled on Android versus iOS versus web? Are they the same? We don't really know. And so, Kotlin Multiplatform has this cool library called Kotlin.test. It follows a very similar API to JUnit. And while we weren't using JUnit on the web for our test suite, we were able to, port our entire web test suite for this piece of code into Kotlin.test and get a separate kind of test runner, test artifact for JS and for JVM. And you run it through their own respective test engines, and sweet, it passed. But how good was our test coverage really, right? You don't really know for sure that your test coverage was catching all the possible bugs in the first place. So a lot of times for us, you write some code, you find a bug in the wild, and then you write a test to catch that bug in the future after you fixed it. But that doesn't necessarily mean that if the test passed, then it's bug-free. So one of the really interesting things about Quizlet is, as I mentioned, we have a lot of users. We use a Google product called BigQuery, which is our data warehousing tool. And BigQuery has this cool feature called a user-defined function. So normally when you're interacting in BigQuery, you're writing SQL functions, and you can run a query across your data to see, oh, how many users are coming in from this new country that we're trying to target. So it's really useful for analytics. But we kind of co-opted this tool and said, hey, let's write user-defined functions to call a JS library. Let's write a user-defined function to call a JVM library and actually run our old JS artifact, our Kotlin JS artifact, and our Kotlin JVM artifact against 16 million real-world user submissions that were anonymized. So we kind of took our unit tests and then also had like a mega fire hose of real-world test data. And surprisingly, after we fixed all the issues that were shown by our unit tests, of course, we found that all 16 million of those things were graded the exact same way across all three artifacts, which was, we expected something to be weird. And, you're happy. It worked. So we kind of validated the shared Kotlin on the grader side was at least correct. So then the next step is trying to answer those questions that we had earlier about, I guess the real next step was, sweet, does it work on Android? The answer is yes. We kind of, as Android engineers, we're used to pulling in Kotlin libraries and using them. That was kind of a no-brainer. We knew it would be easy on Android. But the next real thing was just, what does that look like performance-wise, which was one of our concerns with J2V8 on Android. So we answered that question. This is, there's a lot of numbers up here. The real important thing is that last column. The units are in milliseconds. So the load time, initializing the J2V8 library on Android takes time. Initializing stuff to serialize to and from JSON on Android takes time. And, when you're not using that stuff, you don't spend that time. So our load times on Android for the grader environment went down by 1.5 seconds. It was kind of sad that it was that high to begin with, but that was the state of the world at the time. Marshalling cost. We don't need to serialize anything to or from JSON. We had to do some minor transformations into Kotlin to Kotlin classes, so it still takes a non-zero amount of time, but it was a lot faster. And the grading time, as I mentioned, executing this code through a very simplified, you're calling JVM code, as opposed to going through this intense pipeline, we saw huge wins across the board on Android. So yeah, sweet. Android works. We kind of already knew that. We were Android engineers. We're familiar with Kotlin. We kind of know its ups and downs. So the real scary thing was those unknowns, those questions, those concerns that existed for web. We were in uncharted waters when we were dealing with Kotlin Multiplatform for the web at the time. There weren't too many things out there, especially because most of the writing around Kotlin.js focuses on developing an entire web app in Kotlin.js. We're trying to do a slightly different use case here. We're trying to write a library in Kotlin.js that we want it to be consumed from a real, regular, vanilla JS web app. So it wasn't the most well supported, and it required a lot of really fun Gradle tasks to get this compiling, testing, deploying, and debugging stuff working. We had to write a custom Gradle task to generate a package.json file for every one of these subcomponents in our thing. We had to generate these package.json files, bundle them all together, bundle it with the Kotlin standard library, and publish it to some source that we could pull in from our real web app as if they were node packages. And that stuff didn't exist in the tooling at the time. This was all manual. For testing, the Kotlin.test library was interesting with JS because on Android, or in the JVM by default, it runs things through JUnit. That's great. But with JavaScript, with Kotlin.js, it really just compiles down to, here is a file that you could run in any number of different testing environments, and that's up to you. So you had to write Gradle tasks to actually do that too. And these things weren't impossible. They weren't hard. It was just stuff that had to be done that, at first glance, you don't necessarily think has to be done. JS interop was an area where things got really interesting. We're used to well-typed languages between Java and Kotlin, and hopefully none of you have had to struggle too much with typing in JS, but it's not the best, to say the least. In JS, they don't have the difference between an int, a long, a float, and a double. They have a number. Okay, that's not too bad. Whatever, you can convert between an int and a long and a double and a float. But the other interesting thing is JavaScript doesn't have 64-bit integers. They have 51-bit integers because they reuse the same class for things with doubles. So it's that you lose that precision and that accuracy. And so Kotlin treats, if you have a Kotlin long and you're trying to call it from Kotlin.js, it's not usable as a number on JS. So there's all these interesting intricacies that exist. So collections, if you're using a list or a map and you pass it out into JS land from Kotlin, it doesn't work, it doesn't show up as a list. It shows up as this really interesting JS blob that's annotated with the methods that Kotlin internally needs for it, but it doesn't automatically transform it into a primitive like an array in JS. So that's stuff that we kind of had to handle manually ourselves, which isn't perfect, but it was doable because of the way we defined these libraries in the first place. Like, if you define a library with a narrow enough interface and a very narrow scope that has a very particular goal, you can use all these cool Kotlin features internally, and then at the very last step, just convert it into something that's readable and writable from JS. And that wasn't really hard because we had spent that time up front narrowing the scope of these libraries. And one of the other big things was bundle size. If you look up the Kotlin standard library package on NPM, I think it shows up as like a 2-point-something megabyte download, which is really, really big, especially on the web. No web user is going to wait that long to download the stuff. So the web engineering team was really stressed about that. They're like, this is a no-go. This isn't really going to work, especially because even right now, Kotlin doesn't support the latest module standards in web. It's using Kotlin JS outputs ES5 code and not ES 2015 code. So ES 2015 on web introduces this new way of treating modules. You can import and export modules. You can define things in one file and import them elsewhere. And the tooling around JS has evolved to actually be really good about doing effectively ProGuard. So tree shaking is what they call it in Webpack. And it just ruffles the leaves, sees what falls out. It's like, all right, we don't need this anymore. And we just can't do that with Kotlin JS, even to this day, because Kotlin JS doesn't output something that's compatible with this format. But what Kotlin JS does have is a dead code elimination tool, which is effectively the same thing as ProGuard for Android. It looks at what methods and what fields and what files are being used and strips out anything that's not being used. It looks at what's public and mangles what's not public. And thanks to that tool and the fact that we're not really using the entire Kotlin standard library, like we're familiar with this on Android, where if someone sees the size of the Kotlin standard library and says this is why we shouldn't use Kotlin, at this point, I think most of us are probably pretty familiar with the fact that, hey, if you ProGuard your build, it doesn't really matter. And the same thing applies to web. Once we kind of figured out the right tooling to make that happen, we were able to get the bundle size for Kotlin JS down to 30 kilobytes. And in fact, on web, as you travel from web page to web page, this stuff gets cached. And you can define a separate cache so that you download all the Kotlin stuff on the first page that needs Kotlin, and you never have to even download it again. So this is a one-time cost that users would be paying on Quizlet for the web. So this was actually very acceptable to web folks. But the real next thing was, how does this actually run? Like, we have this test suite of a bunch of different potential inputs from users. How does this actually run compared to real JavaScript on the web? And so we ran a benchmark. Compared to pure JavaScript code, our code from Kotlin JS runs around 3 times slower in browser. That sounds like a really big number, but again, if you look at the units, these are all milliseconds. So it's like 3 times faster, 3 times slower, 3 times faster when you're dealing with numbers this small, for us, was completely acceptable. And also, as I mentioned earlier, this was we just rewrote the exact same stuff as is into Kotlin. There's no optimizations, there's no things around like, hey, maybe we shouldn't initialize these regex matchers this early in the process. Maybe we could use lazies. We didn't even deal with that at this point. So we were actually very, very pleased with these numbers. This, the web engineering team was like, hey, that's fine. Like we push out features that have impacts at like the 1 extra millisecond time all the time. This is actually doable for us. So sweet, we can use Kotlin on the web. What about iOS? This is where we cheated. At the time, the Kotlin native tooling was not the best, and it was changing way too quickly for us to be able to keep up. And we already had those wrappers from when we were dealing with JavaScript on iOS. So why don't we just take the Kotlin JS output from web and shove it into those same JavaScript core wrappers? That's what we thought at the time. And that's what we did. And surprisingly enough, we actually ran benchmarks on this too, because we were like, this is where things are likely to get the most complicated, right? And performance was actually faster on iOS with the Kotlin JS output. That was really interesting to us, and we didn't question it too strongly. It was just like, okay, maybe this dead code elimination stuff does stuff a little bit better than what the web tooling did at the time. And we're like, cool, we'll take it. We'll take the win. So we kind of at this point proved out that it could work. It was technically feasible for shipping libraries across our platforms. It wasn't perfect. Performance on web did go down. Bundle size on web did go up. We weren't really using Kotlin native on iOS. So there were parts that were rough around the edges. But because we had designed our APIs very simply for these libraries, it was doable. So the next step is obviously, hey, let's go all the way with this. So we took this is where we were, and this is where we ended up. And so we just ported the rest of our code into Kotlin, our shared code into Kotlin, because we had this existing framework of shared libraries already from JavaScript. So because we had done that work up front, we were able to get this done pretty quickly. And we shipped it on Android really quickly and saw the benefits as well. So our APK size, because we didn't have this giant JavaScript library anymore, our APK size fell enormously. Our app launch time fell enormously. We're not using this expensive, heavy library anymore. But one of the really interesting things was that mobile engineers at this point, iOS engineers are familiar with Swift, Android engineers are familiar with Kotlin. Mobile engineers felt empowered to work on this stuff. So the next thing was this module called Next Action. It's a bit poetically named, right? It's the next step in what we did in Kotlin, and in the app, it's basically a state machine that takes in a user's study history and their activity to predict, hey, this is the next thing that you should be studying. Like you should use this alternative study mode for this content because you did an easier way before. So you should keep challenging yourself so you'll learn. So it tells the user what their next action is. It was also our next action when working in Kotlin Multiplatform. And the interesting thing here was that we started from a clean slate. There wasn't any prior code to port. There were no prior JavaScript core wrappers for iOS to reuse. And so this was the first thing that we wrote that actually used Kotlin native on iOS. And the other interesting thing about this was that it was written by people who had never written shared code using JavaScript at Quizlet before. So these are people who are able to contribute in a really cool and meaningful way to our business, who before weren't really able to contribute across all the platforms. This was a pretty big success, because it showed us how far we'd really come from porting old code, figuring out how do we integrate with all the build systems across these platforms, how do we validate the performance and the correctness of this code, all the way to, sweet, now we can use this tool to write new code and move a lot quicker. And it's only really gotten better from here. So, we were actually using Kotlin Multiplatform in production with 50 million users across all three platforms like 6 months ago. But what's so special about right now? So I'm just going to kind of breeze through a bunch of stuff that JetBrains has done that we had to deal with before that hopefully you'll never have to deal with again, just to kind of show like this is stuff that is really good in the ecosystem right now. So the Gradle project structure, the old way, you'd have to define one file to say, I'm going to define a common module. And then you'll say, all right, sweet, now I'm actually going to define another Gradle module to call this stuff from the JVM. You had a separate module for your common stuff, a separate module per platform, but it's all representing the same chunk of code. And then when you start to add more platforms, you end up with a lot more files. You end up with around 4+ files for a single library. And as I showed you earlier, we had around 5 or 6 and now like 7 separate shared libraries. This is around 30 Gradle modules to really represent 7 discrete chunks of code. And refactoring isn't easy. What happens if you rename things? It's just not, it just doesn't work. So the near way, you define one Gradle file and you just say, these are my targets. And Gradle automatically handles defining these source sets for you and making everything a lot easier to use. Platform annotations. You had to do all this crazy stuff to be able to use JVM field in your code. Now Kotlin has this thing called an optional expectation. If it doesn't exist on a platform, it just erases it. And this saves us a lot of time. Testing setup. We used to have to download Mocha to run our tests. We had to manually invoke Mocha. We had to consolidate all of this code together, all the test results together for CI. Don't have to do it anymore. You just declare you have a browser environment, and it automatically handles all this stuff for you. There's a bunch of stuff that they don't do, but basically, is now the time to dive headfirst into Kotlin Multiplatform? I can't really say that it is for everyone, but now is really the time to start thinking critically about your projects. Do you have parts of your code base that set you apart from what everyone else is already doing? Do you have a secret sauce that you can or should isolate? You should be thinking about that kind of stuff, because if you do think about that stuff and isolate it the way that we did at Quizlet, you can evaluate tools like Kotlin Multiplatform in a much more streamlined fashion. Our journey doesn't necessarily apply to everyone, but the thought process behind how we identified what parts of our code were shareable do kind of translate across all parts of the industry. So yeah, maybe Kotlin Multiplatform isn't for everyone, but thinking about the important parts of your code base that maybe should or shouldn't be rewritten, that's the thing that everyone should be doing. So yeah, hopefully you all took off some interesting thoughts from this talk. We don't have time for questions now, but feel free to find me, hunt me down, and I'll be happy to answer anything that I can.